Yeah, we'll go over homework later. That's a good idea. Good call. Oh, so everyone got this? Yeah. Oh, what? What? Oh, this should be 10 and 1/3. So that really, if you want to enter it into the calculator, that's 10 plus 1/3. Oh, and this one? Negative 1 3/4. 100. Yeah. Okay. So that's all obvious. So, all right, we did that. Okay, so I just have to go over long division for 1 second. We kind of did it when we did those do nows. No, we didn't. Hello? We didn't do it. Is this on yesterday's? Yeah, I gave you the homework answers, so you can check that out. Yeah, this is on yesterday's because it just goes easier if you remember. Okay, long division. Just to, it's probably been a while since you did this with numbers, so we're going to be doing this with polynomials. So I just got to go over this. So you don't try to divide 12 into the whole thing right away, right? So it does go into 34. Wait. So first you look 12 into 34. How many times does it go? Two. Once you put that up here, focus. What do you do after you put that 2 up there? You multiply it back, right? And then what? You subtract. Okay. Then you bring down the 8. We're going to do this again. 12 into 108. 9, right? You put that up here. Multiply back. Subtract. And what after you subtract? You bring down the 7. Oh, that's right. Now, yeah, 12 doesn't go into that, right? 7. So it's 0 times. Goes into 0. Then we can bring down the 3. 6 times. Up there. We multiply back. Now we got this remainder. And what are we going to do with that remainder? Plus 1 12. Put it over the divide. Okay. It's a lot of fun. Okay. Now, now let's go ahead and divide polynomials. Good old pre-calc days. You're thinking of synthetic. We're doing long division. Yes. I just had a very good tip. If you're missing an x squared or an x, you want to hold its place with a 0. But this time we have everything, so it's good. So we want to divide x minus 2 into x cubed. 2x squared minus 3x plus 4. You don't try to do everything at once. All you do is you say, okay, just like we just divide the 12 into the 34. Can you remember we tried to go into the whole number? Well, we're just going to say, what do I multiply x by to get x cubed? Or how many times x squared? So I put that up here. Now, after you put that up there, what do? Multiply it back. Now I have x cubed minus 2x squared. Like that. And then what do? Subtract. You can add the opposite. Just like we do with numbers, you can subtract. So I had 2x squared, and I'm subtracting negative 2x squared, 4x squared. If you did it right, you shouldn't have an x. Okay, now so I subtracted. You remember what we did next after we subtracted? We, will we bring down the next term? Now we're going to do it again. So x is 4x squared 4x. After you put that up there, what do? Multiply back, subtract. What do we get? 5x. We have to bring down, that's the subtract, down 4. Oh, I can't do that. Get it? And then we do it again. Put it up there. 5. X goes 9. Multiply back. 5x, 10. Subtract. What's our remainder? 14. Now I'm not just going to leave that remainder down there. Yes, this is 14. X 6. Now, the reason we have to know this is because whenever you go to integrate, well, any rational expression where the numerator has a degree that's not less than the denominator, you're going to have to divide first. So it's got to be basically like a proper rational function. Let's take a look. So you go to integrate this, and you're like, oh, this is improper, right? The degree up here is not less than the degree down there. So whenever that happens, we have to divide first. Then we'll integrate. Bless you. What is the clock say? What is the word say? 11:10? Okay, good. Good. Okay. So first, we're going to have to divide because there's 3. And if I was missing an x squared term, I'd write plus 0x squared, just the whole place, get all messed up. But okay, first, 5x, yeah, 5x minus 3. That's our remainder, right? So we're going to write that, bring it up, plus 5x minus 3, what's the x squared minus 2x minus 3. Alright, first of all, there's no complaining about the examples. Right? So now, remember what we were trying to do. We wanted to integrate this, which is equal to that. So I'll just integrate that instead. Well, we want to find the antiderivative of this. But this is equal to that. So let's see the antiderivative of that. So we're going to take now the antiderivative of 2x plus 5x minus 3. Really, it's not so bad. Do them separately because with addition or subtraction, you can integrate them separately. I'll do the first one. And you guys do the second one? Okay? This way, we're right. I'll go first. Okay, so I'll integrate the 2x. Okay, your turn. How are you going to integrate? You sub? What is that? Partial fraction decomp. That's why this is in here. Oh, so we are going to have to integrate this. Oh, it just gets better and better, doesn't it? So since we're going to use partial fractions, let's just factor that denominator right now. See, I'm just going to let you know that kids always forget to put in their answer first part. They get so focused on this. Don't forget about this. I'm going to write under it. Remember. Okay, that's that. Don't forget them in your answer. All right, but now we got to get that. We're going to break that up, and then we'll integrate it. It's going to be good. So, get back to that. We want to break this up into. Now we know the denominators, right? Put the x minus 3 first. Doesn't matter. The the numerator first. A. Okay. And next one. Good. Now, we do up. Yeah, you're going to multiply both sides by the common denominator. So each side. You can't get distracted. You got to remember what you're doing. So we multiply each side by x minus 3 times x plus 1. We get 5x minus 3 equals. Nice. Okay? You got to solve for A and B. You got it ready? How'd you get it? She guessed. Okay, that is bad. Yeah. Wait a minute. Well, first of all, why are you not asking Oliver what to choose for F? Okay. Well, what kind of featureitis techniques you're using? Alright, we'll plug in negative 1 in. You're still smiling? Okay. So B equals 2. Alright, that's one of the numbers we need. But we are not finished. Now we're going to let let x equal 3. Alright, so what is the left side? A equals 3. Those are the numbers we needed. Are we done? No. Alright, so A equals 3 and B equals 2. So remember, way back when, we had the x squared, right? But we still, so our answer so far is x squared. But now we know the A was over the x minus 3. Was A 3? No, it was 3. Okay, so it's 3 over x minus 3 plus 2. Okay, over x plus 1. Whoa. Erase all this. Okay, so let's write down our final answer. We've got the x squared. That was there. Nice. Woo! So the moral of the story is, sometimes you have to do a little long division first. The degree in the numerator is not less than the degree in the denominator. Not too bad, right? You just got to remember the part of your answer that was first. Oh, we're never going to have to do this. But just so you know, it is possible you have so many factors in the denominator that you wind up with like 5 equations, 5 unknowns. It's something like this you would want to use a matrix for. You put it in that row reduced echelon form. Don't worry, we won't have to do it. Or, with the exam, it's going to be easy stuff. But it is possible to solve 5 equations, 5 unknowns. Now, I don't know if you remember yesterday, we were talking about if you have a repeated factor, you gotta account for every power of that one. So how many fractions do you think we would need if we were going to break this guy up? That was good. Oh, that was good. Oh, sorry. Angela, you hurt me. Okay, so the answer is 4 because you would need, the 1/3 I could probably pull out, but let's just say I need this one. Oh. Okay. I would need a 3x. I would need an x plus 2 to the first. I would need an x plus 2 squared. And then I needed one with an x plus 2 cubed. When you have those repeated factors, you can have four unknown days. Don't worry about it though. Okay, so how do you know you're going to have to divide before you start ready? How do you know? You go to integrate the rational function. When the degree up top is either greater than or equal to the degree in the denominator. The degree up top is not less than the degree in the denominator. So the degree of the numerator not less greater than or equal to this less yeah greater than or equal to not less greater than or equal to the degree of the denominator. Now I still have 4 minutes. We can check over a homework problem. Questions on these? I think the last maybe you had trouble. I gave you the answers, so at least you have them. If we run short of time, so you can check your answers. But if you want to see, wait, you didn't do 11 yet, right? You ready? Because 11, you're gonna have to divide first, and the little partial fractions. All right, let me stop recording this for a second, so we can tell secrets.